Okay, so today we're going to talk about how to use point slope form to write a linear equation. So this is what point slope form looks like, and I'll explain this a little more later. Okay, but first let's look at our slope formula. So if you remember, our slope formula is just the change in y divided by the change in x. Okay, and then if we had 2 points, so if our first point was x1, y1, and our second point was x2, y2, okay, so in order to find the change in y, we would subtract the both y's, and in order to find the change in x, we would subtract both the x's. Okay, so that's what our slope formula looks like. Okay, and if we want to get rid of the fraction, we would multiply both sides by the denominator, and then when we simplify our equation, we get this. Okay, and this is where our point slope form comes from. Okay, alright, so why do we use point slope form to figure out how to write the equation of a graph? Okay, well, if you look at this graph right here, you can see that it's kind of difficult to tell what the y-intercept is. We know that the y-intercept is somewhere in between 3 and 4, but it's hard to eyeball exactly where the y-intercept lies. Okay, so let's go through an example of how we would use point slope form to find out what the y-intercept of this graph is. So first, what we're going to do, we're going to pick 2 points on this graph. I'm going to pick 4, 1, and I'm going to pick -1, 4. Okay, and my coordinates for those 2 points are written right here. So I'm going to say that my first point is 4, 1, and my second point is -1, 4. But it doesn't really matter. Okay, and I'm going to plug this into my slope formula. So I'm going to take my second y coordinate, which is 4, minus the first y, which is 1. And then the second x is -1, minus the first x, which is 4. Okay, and that equals -5. So my slope is 3 over -5, or -3 over 5. Okay, so we're going to take this slope and plug it into our point slope formula. Okay, so this is what our point slope formula looks like. We're going to plug in -3 over 5. And we're also going to pick one of these points. It can be either one, but I just picked the first point, 4, 1, to plug it into here. So x1 would be 4, and y1 would be 1. Okay, and what I'm going to do now is I'm going to try to change this so that it looks like an equation written in slope-intercept form. And how I would do that is I would distribute the -3/5 to get that. Then I would add 1 to both sides, so to isolate my y. Okay, and then I would combine my like terms, and I get y equals -3 over 5x plus 17 over 5. So, as we can see here, oops, there should be an x right here. Here we go. Okay, so as we can see here, our slope is -3 over 5, and our y-intercept is 17 over 5, which is, I believe, 3 2/5. Okay. All right, so now let's look at another example. Okay, so we're going to look at this graph right here, and as you can see, we can't see our y-axis. Our y-axis is way all the way over here, but we're not able to fit our y-axis in our graph, so it's kind of hard to eyeball what the y-intercept is if the y-axis isn't even on the graph at all. So what we're going to do is we're going to pick 2 points on this graph. So we picked 12, 2, and 13, 7. 12, 2, and 13, 1, 2, 3, 4, 5, 6, 7. Okay, so now let's find the slope for these 2 points. We're going to plug it into our slope formula. This is our slope formula. Okay, y2 is 7, y1 is 2. And then x2 is 13, and x1 is 12. So our slope is 5. Okay, so now we're going to plug this into our point slope formula. Okay, so we're going to plug it into M. And I'm just going to pick my first point to plug it into x1 and y1. But again, we can also pick the second one if we want. Okay, so 5 times the quantity of x minus 12 equals y minus 2. And then we're going to distribute the 5. Okay, and then we're going to try to isolate y, so we need to add 2 to both sides. And then we end up with y equals 5x minus 58. So here, our slope is 5, and then our y-intercept is negative 58. Alright, so what if we were just given 2 points and no graph at all? Okay, so how we would do this is we would, again, find the slope of these 2 equations. Okay, so these are both our points. I said that the first point was negative 4, 5, and the second point was 2, 3. So the second y minus the first y, 3 minus 5, is negative 2. And then the second x minus the first x is 2 minus negative 4, which is positive 6. So our slope is negative 1 over 3. And I'm just going to stay consistent and use the first point to plug into our point slope form. And we get this. So negative 1 over 3 times x minus negative 4 equals y minus positive 5. Then we're going to distribute the negative 1/3. Okay, so this is kind of tricky here. We have 3 negatives, so a negative times a negative times a negative is a negative. Okay, and then now we're going to isolate y by adding 5 to both sides. Okay, and then we combine our like terms, and this is what we get for our equation. So our slope here is negative 1/3, and then our y-intercept is 11 over 3. Okay, lastly, how can we check if our equation is correct? So the last equation that we found was y equals negative 1/3 x plus 11 over 3. So what we would do is we would plug in each point. So first, plug in negative 4 or 5 to see if our equation is equal, and it is equal. And we would plug in our second point, 2, 3, to see if that's it equals, and it does. So now we know that our equation is correct.